to my channel. We're continuing on in Chapter 5, learning about electricity and magnetism. This is Lesson 70, and we're going to be in both our student book and our activity manual today. In our student book, it will be pages 102 and 103, and our activity manual, page 81. This is a little different lesson. This is not a lecture. This is a demonstration or an activity that you can watch me do, and then you can try at home. So let's get started. Yesterday in our lesson we learned about current electricity, and in order to have current electricity, the electrons or the negative charges have to keep moving. Well, they need two things for those electricity or electrons or negative particles to keep moving. One, you need a power source that's pushing those electrons, and then it needs a path for it to follow. And we learned that the path that negative charges can follow is made of conductors. Now, if you remember conductors are usually metal, and that allows negative charges to move through it easily. We also learned of another word, insulator, yesterday. Insulator means it stops the moving of negative charges. It doesn't let negative charges pass through it. So in this one, we're going to have some different items that we're going to test whether or not it is a conductor or whether it is an insulator. So let's go ahead and look at our student book. We'll read the top paragraph and then we'll get right into our procedure. It says, what would you do if you and a friend were trapped in a bank and the circuit that opened the emergency release lever was broken? How would you get out? Could you find something that could complete the circuit, meaning make it unbroken? Because if it's an open path, the electrons are not going to move. We have to have a closed path. So the path of electricity that opens the emergency door to the bank, you're trapped inside. That path is broken. What could you use to connect or to close that circuit to make the emergency door open? Let's keep going. Knowing about conductors could help you complete the circuit and get you and your friend out of the vault. In this activity, you will identify or name which items are conductors. Okay, so we can set our student book aside. And I apologize for how dark it is in here. We're doing an activity today, and again, it's going to use my little light bulb you can see right here. And we're going to test whether or not these different items are conductors or are they insulators. If it's a conductor, what do you think will happen to that light bulb? Well, if you guessed it will light up, you're correct. Why? Because the path is complete for those negative charges to move. So let's look in our activity manual on page 81. Now, we always start with a problem when we have an activity. And that problem is usually in the form of a question. It says, what items can you use to complete a circuit or to close a circuit to let those negative charges move? What items could be a conductor? That's what we're looking for. So our materials, I have them all up here. Now, in your picture in your book is a little different from what I have here. They have a separate large battery and a separate light socket and light bulb. But mine is all connected into one little thing, one little device. So mine setup is just a little different. But if you look at the picture here and follow what they do, it will work just the same. But you will need, if you're using the idea in your book, you will need electric tape. Electric tape is black in color, and it's an insulator that will protect your hands from electric shock from the battery. So mine, I don't really need it because of the way it is set up. Okay, but the other items we're going to be using is a piece of aluminum foil, or it's made of aluminum, which is a kind of metal. Then we also have, it says a button, but I didn't have a button, so I used this plastic clip. I don't know if you can see that. It's a plastic clip. And then a craft stick, or you can even use after you're finished eating an ice cream. You can take this and use this in your science experiment. It's just a piece of wood. And then I also have a key. This is my classroom key. We're going to use that. And then also a penny. A penny. All right, so I have some other things that we're going to test. It gives you 2 blanks here that you can put your own choice of things. So you can use what is listed, and then you can add 2 more things. So just write in the blank space 2 items. It can be any random item that you want to test. Just write it down. So I picked up 3 things. I have a golf ball, and I have a nail, and I also have a rock. So I picked up 3 items that we're going to also test in our project. Okay, so not only write it at the top, but in the procedure, write it in the bottom and in the chart, in the yellow chart. Now, okay, so here you list your 2 items. Here we always do a hypothesis. In this case, it is a prediction. So you read each one of these items. Do you think, yes or no, is this a conductor or is it not a conductor? Will it complete the circuit or will it not complete the circuit? So we're only going to do these 2 columns together, okay? And then after our procedure, then we can go ahead and finish the other 2 because those are our results. So first we do our hypothesis or what we think are going to happen, then we do our procedure, and then we write down our results. And then at the very end, we will do the conclusion together. All right, so the first thing is listed is the aluminum foil. All right, so here's my ball of aluminum foil. Here's my light bulb. You watch this. I'm going to set that right there. And I have both wires connected to my battery. And you tell me, yes or no, this will complete the circuit. What do you think? All right, here we go. 1, 2, 3. Watch the light bulb. What happened? The light bulb lit up. So is this a conductor? Yes. Why? Because it lets the negative charges move. So this would complete the circuit. All right, so let's try the next thing. It says a button. Well, I don't have a button, so I'm using this plastic clip. All right, so I'm setting it here. Here's the light bulb. Let's watch it. Let's see. Will it complete the circuit? You guess. Yes or no? I hope you have your chart finished before we do this. All right, here we go. Oh, we can't block the light bulb. All right, here's one end and here's the other. Oh, did the light bulb come on? No, that means it's not a conductor. It would not complete the circuit. You could not use a button or a plastic clip to complete the circuit. All right, let's go on to the next item. We have our craft stick. We have this piece of wood. Do you think yes or no? This will complete the circuit or make the light bulb turn on. Are you ready? 1, 2, 3. Oh, that light bulb didn't come on, so it is not a conductor. It would not complete the circuit. All right, let's move on to the next one. It says we need a key. So I got my classroom key. So you take a guess. What was your prediction? Would it complete the circuit or would it not complete the circuit? What do you think? Ready? 1, 2, 3. The light bulb came on. So is this a conductor? Yes, this is a conductor. It would complete the circuit. All right. So we have our penny. Penny is made of copper on the outside. Do you think this is a conductor? Can you see my penny? All right. You tell me yes or no. Will it complete the circuit? Are you ready? And 1, 2, 3. Yes, this is a conductor. It did make my light bulb come on. That means it completed the circuit. And therefore, we could use a penny to possibly save us from getting out of that vault. All right, so that completed the circuit. All right, so I have my 3 extra items that I'm going to choose. I have my rock. What do you think? Do you think it's possible that a rock could be a conductor? Well, let's test it and find out. All right, you take a guess, yes or no. Who says yes? Who says no? You can even leave a comment before you see this, that no or yes, it will be a conductor. Let's test this out. And ready? 1, 2, 3. Uh-oh. It is not a conductor, meaning there's not metal present to conduct the electricity. All right? Or it's very possible that there's a coating over top of this rock. It's very possible that it's stopping it from conducting. But I don't see this as a conductor. Okay? All right, so no for that. How about my very, very large nail? Okay? Let's see if this is a conductor. Ready? Watch my light bulb. Do you think it is? Yes or no? Ready? 1, 2, 3. It's lighting up. Very good. So this is made of metal. It is a conductor. Therefore, it would complete the circuit. I have one more item. I have my orange golf ball. It likes to roll around. So let's see. Do you think that this golf ball would be a conductor? Would it complete the circuit? All right, let's test it out. Watch my light bulb. Ready? In 1, 2, 3. No, that light bulb did not come on. So therefore, it is not a conductor. It would not complete the circuit because you could not use a golf ball to help your friend out of the vault. All right, so go ahead, and now that we're finished, you can complete the results of which ones completed the circuit and which ones did not. And you can test all sorts of things with this project to see whether or not it's a conductor. All right, so your little bit of homework is to finish the conclusion. There are 3 questions at the bottom to review what we did in our activity. I hope you enjoyed this and learned more about what are conductors and what are not conductors and what could help you in an emergency situation when your circuit is broken. I'll see you next time.